Okay. Thank you. So yeah, thank you for attending my talk today. My name is Flavio Brasil. I work here at Twitter. I work on the core data libraries team. And we basically work on Scalding, Hummingbird, and a little of Spark as well. But today I'm going to talk about a personal open source project that I've been working on. So initially, the title of the talk was Spark Datasets, why they aren't great, and what could be done about it. But actually, I decided to do something about it. So the title of the talk now is Quill Spark, a type-safe Scala API for Spark SQL. Okay. So I would like to start with a brief history of the Spark APIs and why the APIs were introduced, just to understand how this new API came to be. So in 2014, the first version of Spark was released, and the first API was RDD. So most of you probably know RDD. And this is an example that I'm going to be using throughout the talk, that is, given a collection of tweets, return the top hashtags. Okay? So first we flat map, get the text out of the tweet object, split into words, and then we filter only hashtags, and then we map to lowercase hashtags. And this is not too intuitive, but basically you create like tuples with the word and a counter, right? And then you reduce by key, so the key is going to be the words, the first element of the tuple. And we reduce the second value to the counter, so we have a count of each word, hashtag word, in the group of tweets, in the data set of tweets. And then we call top n, ordering by the second element of the collection, and we get the top hashtags. Okay? So this is a nice API. It's type safe. You can use Scala Functions. You can use Scala types, and that's totally fine. But it has some downsides. So one of the problems is, for instance, the users can introduce inefficiencies. So here we have a filter operation. And if we move the filter operation to after the reduce by key operation, it's the same meaning, right? We are going to have the count for all words, and then only filter the words that are hashtags. But that's much, much less efficient, right? Because you are going to do a shuffle for all words and then only get the ones that are hashtags. So that's not really efficient. And that's a problem of the API. For this case, it's easy to see it's not efficient to move the filter. But there are many other more subtle scenarios where the user can introduce inefficiencies. So that's really a problem for the API. The second problem are the Scala functions. So when you call flat map and you have a function that reads the text and split into words, this is something that is just for the Spark execution. It's just a pointer to some byte code. It doesn't know anything about this function. It doesn't know that it uses the text column, doesn't use any other column, for instance, or it's going to split the text. And this means that it limits the number of things that Spark can do with this transformation. So if tweets are coming from, for instance, a columnar format like Parquet, it would be much more efficient to load only the text column and not load any other column. And that's like orders of magnitude more efficient, for instance. But Spark can do anything because it needs to have a full tweet object just to call this opaque function, Scala function. Another problem is the API introduces, has transformations that return RDD, and it also has actions. So depending on which method you use, you can do just a transformation that's going to be executed later, or you can actually bring the data to memory. So here, the top operation is actually bringing the data set to memory. And it's really common to see newcomers, people learning, or even people that are using for a while big data solutions, bringing data to memory without understanding the actual implications of this operation, right? So that's why that's not so ideal. And then, as a way to improve that and give Spark a better way to optimize the execution of a job, in 2015, the Spark community started working on something that is actually using something old, that is SQL. So with SQL, if you see a SQL query, you have all the information about what's going to happen, right? You have all columns that are going to be used. You know about all transformations because it's just a string that you can parse. So that's something really the execution engine can introspect any aspects of this transformation. So and then a new API was introduced as a way to build this kind of SQL query that is Dataframes. And Dataframes are not so great, but they have a very nice property. The execution engine knows everything that's happening. So for instance, the explode, split, select and explodes is more or less like flat map for Dataframes. And then you split, so the execution engine knows that only the text column is going to be used, for instance. And it can load only the text column from a columnar format. Or it knows that it's going to explode or split and apply more optimizations to the execution. And also, you can move the filter. So I could move the filter to after the aggregation, and Spark would be able to optimize the execution accordingly. And that's something that's much better because you don't need to worry too much about subtle scenarios where you can introduce inefficiencies. And in 2016, another API was introduced. So the data frame is fully untyped. You don't have like a data frame of tweet. You have just data frame. And in 2016, a new API that is Datasets was introduced. This is how you do the top hashtags using Datasets. And it's like a mix between RDD and data frame. So you have some operations that are untyped data frame operations, and you have operations that are dataset typed operations. So you go back and forth between things that are typed and things that are not typed. And you can do interesting things because, for instance, like the select is going to use the text column, and the execution engine knows about that. You can also use the flat map as a Scala function, regular opaque Scala function. But there are some problems. For instance, let's say that instead of selecting the text and then doing a flat map, I replace both operations with a flat map that reads the text and splits into words. So it means that Spark doesn't have the information about the columns that are going to be used anymore, because that's an opaque Scala function. Make sense? Another problem is the type safety. So if you reference a column, you have to say the type of the column, and that means that you can make mistakes and have runtime errors. And type safety is a really important thing for Scala developers, right? So that's the problem. Basically, like the Dataset API has like this. In one hand, we have type-safe Scala functions that are not introspectable, right? So you can't see this execution engine, can't see through these Scala functions. But on the other side, we have strings and columns that are not type-safe, but they are fully introspectable, right? So an ideal solution should be able to give the execution engine enough information about the transformation, but at the same time preserve type safety. So how could we do that? So in 2015, I came across this paper. It's a really interesting paper from Philip Wadler and some other people. I don't know if you know Philip Wadler, but he's a very important person for the functional programming community. He worked on Haskell or monads or free monads, so he defined many things that we use today. And he wrote this paper with some other people that is everything old is new again, quoted domain-specific languages. And it's a recipe for building a language interpreted query in any language. So I decided, okay, that's an interesting challenge, so I'm going to implement that in Scala. And I released in 2015 the new open source project called Quill. So right now it's mostly a database-centric library. So it's very mature. You can talk to Cassandra, talk to Postgres, to many types of databases. And we are at the 2.2 version. We have a maintainers community. And it's one of the most popular solutions for database access in Scala. And now we have a new module that is a Spark integration to use the Spark SQL engine. I'm going to give an example just to show you how Quill works. So here we have a simple query. So selecting from couples, and then where one person is older than the other, and then selecting the name of the older person and the difference of age to the other person. And it's a very simple query, and that's something that can be expressed in Scala very similarly, more or less with the same structure that is using for comprehensions. So let's say that couples is a collection in memory, people is a collection in memory. you can use for comprehensions to apply some filtering, get one person, other person, couples, and then yield the result. So the yield is the select clause in SQL, the if is the where clause, and the body of the for comprehension are the from parts of the query. But that's really nice. Like we are using Scala, we are using typed transformations, but that's something that we don't want to do. We don't want to load everything from the database to just to run some queries. We don't want to load all couples, all people. So what can we do? There is a technique that is actually an old technique called quotation, and the paper that I used to develop this library uses this technique as well. And it's interesting because it's using the code as data instead of code that's going to be executed. So we wrap this block of code with quote. And what's happening here, the quote method is a macro method, and it's going to receive a parse tree from the Scala compiler, and then transform this parse tree into an internal AST. So you use this block of code, instead of being something that's going to be executed at runtime, it becomes information for generating an internal AST. And this is more or less the AST. It's not possible to read it here. But it's a very simple AST. It has all the information, so it can see through flat maps. It can see everything that's happening in that computation, right? And then what the paper defines is a set of normalization rules. Sorry, it looks super complex or hard to understand, but this is something really, really elegant. If you see the same transformation implemented by Slick in Scala or Microsoft LinkU, it's like thousands of lines of code, and this is like a couple hundred lines of code in Scala. And it's much more reliable because it's based on a theory and transformations that are principled. So what Quill does is get the AST using quotation, pass through this normalization engine that is based on the paper, and then from the Scala code, we can generate the same SQL statement. So that's what Quill does for database access. This is a demo of Quill because it does something more that is compile time quotations. So you can do like a quotation that's a query fetching people with name John, and then pay attention now when we run the query. You can see the generated query at compile time. So the quoted ESL that Quill implements, it's a compile time quoted ESL, and it is able to generate the final SQL statement at compile time as well. So you have very nice feedback loop, and you also have better performance. And there is another thing that I do here in this demo. I change the column age to age E, and then the compilation fails. Let's see here. So that's the first demo, like showing the query, and then I change the column, and the compilation fails because it knows the query at compile time, so it can be configured to access the database and probe the query against the database. So that's something that is possible to do with Quill as well. So I've been working on this. That is a version of Quill with an integration for Spark. It's very similar because Spark has a SQL API. So you can call Spark SQL context.sql and pass a SQL string, right? So I integrated Quill with this API. So this is the top hashtags using Quill. So we use this run method that is also using quotation. It uses implicit quotation, but this block of code is going to be quoted. And then I can lift a data set into a Quill query, right? And then this is more or less like the flat map that we have for RDDs. But that I call concat map. I'm going to explain that later, but it's very similar. And I can also, like, for instance, move the filter, and that's going to be fine because the SQL engine is going to be able to move the filter back to the best position in terms of efficiency. And also, the API is totally lazy. When you are within a quote block or a run block, everything that's there is going to be generating a SQL query. So you don't need to worry about having something that's going to be called and bring things to memory like actions. Everything is lazy. Everything is easy to reason about. So yeah, so that's the SQL that Quill generates. from that Scala API. And as I said before, the Spark SQL engine can apply so many optimizations because it knows every single thing that's going to happen in this computation, right? So as a last note, Quill has a monadic API. My background is mostly backend systems, so I was working on the tweets microservice, but I changed teams and started working with big data solutions. And one thing that I really didn't understand at first was the flat map function that's calling our RDDs, Dataframe, Dataset they have. It's a function, it receives a function that receives, that returns a traversable once, right? So if normally flat map implements the bind operation of a monad in Scala, right? So I would expect something like this, but that's not the case because RDDs and Dataframe datasets called in typed pipe, they are all applicative. So you can compose them as a monad. But actually, Quill queries are monads. So you can do flat map and return a query, and that's going to be better composable. So just one example of composability here, it's a query that returns couples with the same age, right? So we use a far comprehension, use lift query for one person, another person, couples, and then join by the couples table and find people with the same age. And that's like something that's much easier to do with Quill than doing with RDDs or an applicative API. So that's what I have. If you are interested, please try it out. Give us feedback so we can improve the new integration. I think it has a lot of potential, but it depends on usage, if we have users, right? And also, I would like to say that my team here at Twitter is hiring. So if you're interested in working with me or scalding some birds, let me know as well. Feel free to grab me and talk after the talk. And I think we have time for one question, maybe.
Yeah, we have time for questions. Just a question on how well do you pick up UDFs and put those into the SQL?
So as Quill is integrating with the Dataset API, you can, if you have a function that is not something that's going to be SQL, you can use just the Dataset API. So you can do a transformation using the SQL API, and then you can do map or flat map using a Scala function. So you don't need to embed any UDF for executing regular Scala code. Make sense?
Let's go the other direction. If we know there's an optimized UDF for it in the SQL.
Oh, I see. Okay.
Yeah.
Okay.
But we write something that doesn't use that.
I see. For Quill, Quill doesn't do the integration with Spark to define the UDF in Spark. You would have to do that by yourself. But for calling arbitrary functions, you can use something that's in fix in Quill that you can call any function or any SQL statement.
So I guess that when there are some things that are illegal inside a code, right? And my question is, how informative are the compilation errors when you put something that is not right and you get good information?
Yeah, that's a good question. So anything that you do within a quotation needs to be something that can be translated to SQL, or else you get a compilation error. And the compilation errors, I can't say that they are great right now, but at least you have this safety of only having things that can be translated to SQL.
Sorry.
So you mentioned there caveats and negatives to RDDs, Dataframes, Datasets. Are there any such things we should be aware for Quill?
So Quill doesn't have all the features that SQL has or Spark has. So you might hit some limitations within the integration between Quill and Spark SQL. For SQL in general, it has a pretty good support for most features, but it's not complete. SQL, for so many databases in SQL have so many differences that's really hard to find to implement all the features, right? So that's one of the limitations. The Spark SQL integration is very young. So there aren't users, I think, right now, so I just released. So that's something to consider as well. Yeah.
I think we've got time for another question, if you're up for it, Flavio.
So Quail is great for people who know Scala and they don't have to learn Scala, but the set of people who know SQL and don't know Scala is infinitely larger. So for these people, you're telling them you get all the great features of Quail, but you need to learn Scala. Have you faced this problem, and how do you deal with that?
So yeah, that's a great question, because we see that here at Twitter a lot, like people that know SQL and they prefer to do SQL. And I think that's totally fine. If someone wants to do SQL, like do SQL is the best way for them, right? But I think the target of this library is more Scala developers that want to do big data and want type safety and the features that Scala provides. But that's a really good question. Do we have time for one more? Yeah? Okay, so last question. Could you pass the microphone?
So I can see that this can be applied to just any relational database. Do you have any plans to do that? And also, how would it compare to something like Slick? And also, if it is very similar, or if Slick can benefit from this kind of quoted DSL, do you have plans to kind of contribute this back to Slick?
So Quail for database access already has features for accessing most databases. So, and Quail also has a superset of the features that Slick has. So it's a replacement for Slick, okay? Or an alternative to Slick, okay? Okay. So I think that's it. Thank you very much for coming today, and yeah, thank you.